Okay. Thank you. Good afternoon to all faculties of PhD and faculties of Bannari Amman Institute and students of PhD and Bannari Amman Institute. And we welcome Tilagvadi HOD Textiles of PhD and Mr. Gopalakrishnan HOD Textiles from Bannari Amman Institute. So welcome you all, and it is a great pleasure to us to again restart our student chapter program in this academic year, and this is our first program, and we hope this year also we will be able to deliver a much better program than what we did last year, and we have lined up a lot of programs for this year to the students, and we expect a good support from the colleges, and any suggestions on the programs also most welcome. And it is very interesting for us also to interact with the students and impart knowledge, whatever we gained in the industries to the students, so that it will be beneficial to them in future. So we welcome you all. And this is today we have a program on quality management in spinning mills. And Mr. Kanthimathinathan, many of you might be knowing him also. He is one of the senior technocrat, and he has a vast experience. So today's program has been specifically designed for the students, because spinning maintenance is so important in a spinning mill. So now we can go ahead with the program. Before going ahead, we request our Mr. Tilagvadi, Madam Tilagvadi, to give about the brief about the student chapter activities, and what the students, how it will benefit to the students, and how we can proceed in the coming years. Your suggestions, please, madam.
Thank you, sir. Good afternoon to all of you. Respected Secretary, sir, Mr. Gandhiraj from Textile Association South India Unit. Respected Mr. Kanthimathinathan, sir. Other team members from Textile Association India South India Unit. HOD Mr. Gopalakrishnan from Bannari Amman. Other faculty members from Bannari Amman and from my own department. Faculty colleagues, participants, student friends from both the colleges, PhD College of Technology and Bannari Amman Institute of Technology. A very good evening to all of you. I also join Gandhiraj sir in welcoming all of you for this webinar on textile quality management in spinning industry. I think if I remember correctly, the Textile Association South India Unit student chapter was started maybe a year ago, and they are successfully rolling their wheels by conducting a lot of technical seminars. It was very much useful to all the students. To name a few, there were topics on costing and industrial engineering. A lot of topics were covered by them. And really it helped the students to face their interviews and also learn the practical concepts in all the theory, whatever they have learned. Definitely it was very much useful. So in this aspect, I would request all the students to participate in all the webinars conducted by Textile Association South India Unit. And you become a member. Maybe it's a very small amount they are receiving for the expenses. It's very, very small amount. And I would request all of you to become a member of this unit. And definitely it has a lot of benefits, like you can stay connected with your professionals, and it will help you network with the professionals in your own field, textile technology. And you can share research, technology, everything can be shared in this platform through seminars, workshops, webinars. And on behalf of all of us from colleges, we appreciate all the members of Textile Association South India Unit for their innovative initiative of starting this students chapter. And I request all the students to make use of this. Definitely, it will be very much useful because maybe for the past 2.5 years, you could not come to the college, and whatever you have learned was all through online mode. And maybe you have learned some theoretical aspects. So once you attend the seminars or workshops or any address with respect to your field through the experts like Mr. Kanthimathinathan or through the association, and definitely they are all having expertise in their own field, it will help you to learn your and maybe hone your skills with respect to your field. And I think at this juncture, I would like to thank South India unit for their efforts in conducting these workshops. And we are sure, I think, from colleges, we will make use of your all your skill related or whatever it is, technical seminars. We will definitely participate, and we'll take the benefits from the activities of South India unit. And coming to the topic of today's, definitely it will be very much useful. The spinning industry is a large industry, and whatever you have learned as students, you might have learned Spanion Technology 1 and 2, and you might have learned 2 subjects in the lab. But when you listen from speakers like Mr. Kanthimathinathan, who has very good experience in this field, and we appreciate that he has also written a book in this area, and his topic of the book is also the same. I have gone through that book. It was very much useful, and he has, based on his experience, he has discussed a lot of case studies, whatever the problems he has faced in the industry and how he has troubleshooted, and that was very much useful. And definitely, if you go through his book, definitely it will be useful. But for that, you may not have those type of case studies from your theoretical knowledge, whatever you learn from the classes. So with that, I would request Kanthimathinathan to continuously share this knowledge or expertise to the students. And Kanthimathinathan sir, as always, is helping us in all our academic activities, and he has a passion towards sharing his expertise with the students. And I think, hope you can listen from him, and you can understand how much expertise he has and how it will be useful to you. Maybe I would like to end my small address with a kural. Katraarul katrar enapaduvar, katraarmun katrasela cholluvar. This is very apt in this situation because the speaker of today's webinar, Mr. Kanthimathinathan, is very good in his expertise, and he is கற்றவரின் முன் தாம் கற்றவைகளை அவர்களின் மனதில் பதியுமாறு சொல்ல வல்லவர் Kanthimathinathan. அவரே கற்றவர் எல்லாவரிலும் கற்றவராக மதித்து சொல்லப்படுவார். So this is very significant in this situation and very apt and significant. With this brief address, I would request all the students to seriously listen to his speech, and maybe you can share your feedback. Students, you will be asked to share your feedback. Listen to him carefully, and you can make a note of it and post your queries through chat box also. And once again, I thank Mr. Kanthimathinathan for his proactiveness in addressing all his expertise to the students. And thanks Mr. Gandhiraj sir for organizing this. Thank you, Mr. Sivaramakrishnan sir, who is at the behind from the back show. He is showing his face. Thank you, sir. And, once again, I thank all of you for your strenuous efforts. And students, please listen carefully and make use of this topic. Thank you, sir. With this, maybe I request Kanthimathinathan sir to proceed.
Thank you, madam. Thank you very much for your encouraging speech on the introductory address. and it will definitely help us to, it has motivated us also. We will definitely put our full efforts to deliver our knowledge to the students. And now I request our Joint Secretary, Mr.A. Sivaramakrishnan, to give the brief introduction about the Mr. Kanthimathinathan. Though he is known to all, there could be few students, I mean those who have joined this year and may not be knowing about him. So we thought formally we will introduce Mr. Kanthimathinathan to the forum.
Respected head of the departments, Tilakvati Madam and Shri Gopalakrishnan, and all of the teaching faculty members and our dear students. Today, our speaker, Shri Kanthimathinathan ji, is a postgraduate in textile technology from PhD College of Technology. He has vast years of experience of about 44 years in reputed mills, Vajra Coats, TVS Group, Premier, Precard, and GTM, and also Citra for a short period of about 10 years. Shri Kanthimathinathan is a multi-phase textile personality and also a highly enthusiastic knowledge sharing personality. So we are very happy to introduce him. He is associated with quality, production, maintenance, and textile mill management. He joined as a floor-level technical officer and rose up to a level of president. There are 9 levels. Starting from first level to last level, depending on the corporate company, it is about 9 to 10 levels. He was able to achieve this high level only because of his hard work, interest, and capability. He is always full of rich resources of knowledge. He is ready to share with us. So kindly, all students, make use of his knowledge and develop your capability. With these few words, I will conclude my introduction.
Thank you, Mr. Sivaramakrishnan sir, for the introduction on Mr. Kanthimathinathan. So now I request our Mr. Kanthimathinathan to start his presentation.
Kanthirathan sir, good evening. I will use share screen.
Yeah. Sir, well, it is open now.
Is it visible now?
Yeah, visible.
Respected Secretary and Joint Secretary of Textile Association, respected Tilakvati Madam, respected Dr. Gopalakrishnan, and academic experts from both PhD College of Technology and Bannari Institute of Technology, and my dear students of both the colleges. Good evening to all of you. Today we are here to discuss about quality management in spinning mills. This program is because of the joint effort by Textile Association of India student chapter, and also with the help provided by Dr. Tilakvati Madam and Dr. Gopalakrishnan and Dr. Ramesh Babu of Coimbatore College of Technology. Thank you very much, Tilakvati Madam, for your praiseworthy words also. Thank you. So let's go into the subject. I am a management committee member of TAI-SIU also. So once you leave this program, so what are the learning goals you will take away from here? Takeaways of the program will be cotton fiber quality. What is incoming inspection, in-process inspection, final product inspection? And what are all the testing instruments for above quality characteristics? So likely we'll touch upon the synthetic fiber properties, and we should also have a feel of TQM at the end of the program. So today you may be having so many network information about the spinning mills in India, but please understand, India is still the most favored destination for foreign buyers due to we are customer friendly. Our customer friendliness is well appreciated, and we always maintain consistency in our quality. And we are transparent. There's no cunningness between. See, whenever you talk about Chinese products, you know very well. If you buy 100 products, it will be 50% will fail. So we don't do any cunning business. We are always transparent in what we do, and we are also ready for tailor-made products. What do you mean by tailor-made products? See, whenever you go to a shop, usually if you are in, you just buy a shirt that is made for somebody. It's a 38 shirt or 40 size. So it won't fit you exactly. But if you go to a tailor and make your own shirt, it will suit your requirements. The fitment in the shoulder or fitment in the cuff, fitment in the wrist, everything will be very good. It will suit your requirements. So likewise, India is ready to supply tailor-made product to suit the requirements of quality from the customer level. And one more thing, most of the buying houses in the globally, they are already started fishing net operations for joint ventures with their own spinning mills like Wellspun, Trident, Eveready Group in Dindukal. There are so many trials are going on for joint ventures and tie-up arrangements because of this fact. Now, quality. What do you mean by quality? What do you understand by quality? Let's say you are going to buy a mobile or you are going to buy a car. You want to drive down from Avinashi Road house to college. What car you will buy? Will you buy a race car? Definitely you want to. Like that, you are going to buy a mobile for your father, aged father at the age of 80. So what mobile you will buy? Will you buy an iPhone or anything to your father? No. He needs only calls has to be attended, calls have to be made. That's all. Simple. And the phone book should have 10 or 12 address book. That's all. So you can go for even Nokia 1100 phone. But whereas if it is going to be for your son who is going to be a mobile business person, what mobile you will be doing? Because he is a business person, he needs a data storage, 5G phone, LED screen, because you will be going through net always. So 3 days charge also it should be. So the purpose for which you are going to buy a product decides the quality of the product. That's one. Then this customer stated requirements. Whenever you go for that, you will say, I need Android system. I need 64 GB memory. I need so many 2 GB RAM, like that. So I need 5G SIM. I need dual SIM. These are all stated requirements. So the next is quality is meant by stated requirements. The other point is a customer's perceived requirements. See, every time we won't say, I need this, but we expect the quality. For example, you buy a phone. After speaking with your friend for 3 minutes or 4 minutes, if the phone heated up, what do you say? Quality of phone is very bad because it gets heated up even in 3 minutes. But you can't go and even then you can go and complain to your mobile shop owner that this phone is getting heated up. He will not say, you are not told me this requirement, because it's a perceived requirement. As a mobile, it has to perform a certain level of function. These are all called perception, isn't it? Like that. Quality should be internalized as a culture. So whether this is from, for example, for you have to supply a very good yarn to the customer. But what do you mean by internalization as a culture? See, you cannot supply a product to a customer without buying a very good raw material. Raw material should be very good. Likewise, your machinery should be very good. Likewise, your spare parts quality should be very good. So The quality should be internalized throughout the industry as a culture. Then only you can supply very good quality product, isn't it? So that's why we mean quality should be internalized as a culture. Now, let's see the definition of quality by Edward Deming. Who is this Edward Deming? Edward Deming is called as the father of quality management, who is a US person, but most of the time stayed in Japanese after World War II, who helped economical production in Japan after World War II. So he is the father of quality management, and his definition is good quality means a predictable degree of conformity. That means you should be able to say this is the level of conformity. This mobile can withstand charge up to 3 days. This mobile can take up 4G network, like that. Predictable degree of conformity and dependability with the quality standard suited to the customer. So this is what is the customer expectation? What is the customer expectation quality standard? See, today we have Worcester quality standard, we have Premier standard, we have Citra quality standard. So customer can go for, I want Worcester 25% standard, or I want Worcester 5% standard. So the dependability with the linked with the quality standard suited to the customer. That's also more. So the definition of Deming is good quality means a predictable degree of conformity. What is the conformity to the specification, and dependability with the quality standard, which suits the customer. So this is the quality of Deming. Now, what is the business definition of quality? Today, what the industry follows, fit for the purpose. It's very simple, fit for the purpose. If you are going to make yarn for sportswear, what is your expectation? Absorbance of sweating is more important. So if it doesn't absorb your sweat during wearing a sportswear, then there's no meaning. Quality is poor. Likewise, swimwear. So after coming out from the swimming pool, you should shake off the cloth and then moisture should go out. So this is what you are expecting in a swimwear. It's a faster dry. When you go to a party wear, when you wear something for a party wear, you expect some drapability. The drapability of the fabric should be good. It cannot be like a military wear where it's rigid look or anything like that. So quality means fit for the purpose. Then the next definition is quality means free from defects. Free from defects. Then you can ask me, what is defect? What is defect? Defect is anything that dissatisfies the customer. Defect is anything that dissatisfies the customer. For example, packing material quality. Or for example, containers. You may have seen some 20-feet container, 40-feet container on roads, which carries a yarn. So if the containers comes with a dirty floor, nobody will export the yarn or stuff the yarn in the container, because looking at the container itself, the customer will throw the goods face onto you. So, for example, packing material qualities. Some example you can see. You go and buy some bakery. In all the bakeries, you might have seen some homemade chocolates. Are you buying that? You are not buying that. You will go and pick some Nestle chocolates or Dairy Milk chocolate. Why? Because you are not only attracted by the packing material quality, but you are assured of the quality of the product inside the packing material. Because the packing material tells you the type of product in this. Like that, why do we prefer multiplex theaters? See, the same Rajinikanth movie Annati is going on screened in KG Theatre as well as Prozan Mall. But why do you prefer to go to Prozan Mall? Because you like, apart from the product quality, that is cinema's quality, you like to have an ambience. You like that ambience. Your satisfaction of product quality, your satisfaction on the toilets, hygienic quality, your seating arrangements, everything you like that. So it is not the product quality alone. The defect can be anything associated with that. Okay. So that means quality means free from defects. Now let's go to the quality management. So we have the several definitions of quality, but Deming's quality is more important one, which you should not forget. When you say it's a spinning mill's quality, we divide into three parts. One is incoming material inspection, and there is in-process inspection. Third is finished product inspection. You can call it as incoming material quality, in-process quality, finished product quality. We divide into three. Let's go on. The raw material in textile industry is more important because it contributes for the 50 to 75% of the total manufacturing cost. If it's cotton, it will be around 50 to 65%. If it's a synthetic fiber, it will be 65 to 70%. The cost of in the cost of manufacturing structure, yarn cost, cotton cost will be 50 to 65%. If it is a synthetic yarn, synthetic fiber cost will be 65 to 75%. So, any negligence in the selection of raw material cannot be corrected by your machinery quality or your process quality or the supervision quality or the managerial quality. So there should not be any negligence on the selection part of raw material. So testing of raw material or testing incoming inspection for raw material is more important. In spinning industry, the basic raw material is normally cotton fiber or synthetic fiber, both of which has lot of characteristics. If it is cotton, there are a lot of variations because it's a natural product. Okay. Testing is the tool for the selection of raw material and then the control of process quality of the final product, as well as the process control, controlling the process, which is more important. So now, as a raw material, cotton fiber, what are the characteristics we need to test whenever you buy a bale, cotton fiber? What are the characteristics you will test? Length and its uniformity. Cotton fiber has length, so 27 mm, 30 mm, something like that. Length and its uniformity. How much is uniform? Some of the fiber are longer, some of the fiber are shorter. What is the portion of short fiber? What is the portion of mean fiber? Something like that. That's all uniformity. Then the fineness. Fineness means thickness of the yarn, thickness of the fiber. Then the maturity level, because maturity is nothing but like what you say, nutrition. So if the nutrition is good, we are healthy. We are taking a lot of nutrient foods. We are healthy. So maturity level means healthy fiber. It's a strong fiber. Maturity and fineness decide the strength of the fiber also. And there is a fiber, how strong the fiber is. Then the trash content. Any cotton fiber will have some trash material. What is the level? What level we can accept when we buy from the buyer? Then the other characteristics called reflectance and yellowness, which we will see. Other characteristics in the cotton is short fiber content. That means short fiber content is a definition. 12.5 mm and below is called as a short fiber content. Then the nippiness in the fiber. What is a ball-like structure, nippiness in the fiber. And stickiness property, whether the fiber can run without sticking on the surface of the material. Then the moisture content, at what level of moisture we are buying. Standard moisture level of cotton is 7.5%. So we can accept plus or minus 0.5. If you buy a dry cotton, you lose strength in the process. If you buy a moist cotton above 9% in the moisture content, then you will not be able to process it properly in the production machine, because in the production machine there will be steel particles, steel parts in which there is a roller lapping will happen. Then the contamination level in which, see, actually this is a cotton is a natural product. It's grown into a field, and then from the field it's plucked, then it is ginned, it's stored in the heaps, then it is taken to the gin. From the gin it is baled, from the bale, all the bales are being transported on road to the mills. So there are several chances for the cotton to get contaminated from the field to mills. So what level of contamination we have in the fields, this also matter to us. Now let's say how the raw material is going to be tested. There is one instrument called high volume instrument. Why we call it a high volume instrument, we will come to know about it. Between 1940 and 1970, we have so many instruments for assessment of length separately, strength separately, fineness separately, maturity quotient separately, moisture content separately, everything. But WINSYS has come out with a high volume instrument which takes care of the measurement of all the properties at a high speed. Today, we can test the 700 samples can be tested in this high volume instruments. What are the characteristics that we can test in this instrument also we will see. So this high volume instrument has been manufactured with the contribution from USDA. USDA means United States Department of Agriculture. You know very well, USDA is the organization which helps to control the quality of cotton in United States from the seed level to mill level, that is mill level delivery cotton. To that extent, they have the control on the cotton products in United States. But we don't have any such organization anywhere in the world except USDA. But USDA, they have developed so many standards, they have developed so many instruments, and this is the best of the instruments manufactured with the help of Worcester. As on date, the most widely adopted equipment made by Worcester Technologies is Worcester HPE, because as we know, raw material is 70% of the cost of yarn manufacturing, and no negligence is allowed. No negligence can be tolerated in the mills. So Worcester HPE is most widely adopted equipment. Worcester HPE tests randomly clamped fiber sample. It can measure multiple quality parameters of cotton fibers. It helps a lot for incoming raw material quality inspection at a faster rate. It is a global reference tool for cotton classification, producing accurate and reliable results. See, whenever you say instrument, this is more important, reliable and repeatability. Any instrument, now you are testing, it will give you 30 mm. The same bale, some sample is collected and tested 27 mm. That means that you are not able to judge the instrument capability itself. You will fail. So the instrument is capable of giving an accurate and reliable results always. See, for example, when a bale number 170 is tested for some characteristics in HPE 1000, you will be able to repeat the same results even if you test it after 5 days time. Okay. It measures all important quality parameters. It also gives additional information on short fibers, cotton maturity, and moisture content. So let us see. HPA is used for what? 2.5% span length, 50% span length, uniformity ratio. What is this uniformity ratio? Uniformity ratio is nothing but 50% length divided by 2.5% length expressed as a percentage. If 50% length is 14 mm, if 2.5% span length is 28 mm, 14 by 28 is 50. So uniformity ratio will become 50, 0.5 or 50%. Fiber strength in gram per text, we are getting that. This is called a fiber bundle strength, fiber strength in gram per text. Fiber fineness is always expressed in micrograms per inch. What is the weight of fiber per inch in micrograms? So that's why we are saying is fiber fineness. Fiber elongation. What is it? This is coming as a elastic property of yarn. This you will deal with this some mechanical properties later. But fiber elongation decides the yarn elongation. Yarn elongation decides end use performance also. So fiber elongation also matters. Fiber elongation ranges from 4 to 6 in Indian cotton, 5 to 7 in imported cotton. Then the short fiber content. Here, the short fiber content is defined as fibers less than 12.5 mm. This is also being checked. Then the reflectance and yellowness. Then it also gives a measure of trash grade. So when you say fiber length, there are various terminologies like effective length, staple length, mean length, etc. But popular and most utilized are 2.5% span length and 50% span length. What is that span length? Let's see. Look into the diagram. This diagram, there are A and B. A is the area where it is clamped. All the fibers is clamped. B is the line where 2.5% of the total number of fibers. Assume 100 fibers are there. In the 100 fibers, only 2.5% of the fibers are extending beyond the line 3. Beyond the line 3. That means AB is the length, AB, the bottom bore, AB is the length, or AB is the extent, beyond which 2.5% of the fibers are extending. That means if AB is 30 mm, then we will say 2.5% span length is 30 mm. Now assume what could be 50% span length, whether it be greater than 2.5 or it's lesser than 2.5. For assessing 50% of the fibers to go beyond a certain length, you have to reduce the gap of AB. Then only you will get the 50% fibers will extend. So always 50% length will be lower than the 2.5% span length. So this ratio, 50% span length divided by 2.5% span length, tells you the uniformity index 1. This 50% length is also called as mean length of the fiber. Okay, this is most important in length, is more important in deciding your drafting settings, your process parameters elsewhere. Okay, even the strength of yarn is decided by this length parameters. And then this is explained by you. 14 mm and 30 mm, UR will be 47%. Okay. The next is fiber fineness. Is nothing but a measure of thickness of the fiber. Based on the fineness of the fiber, we call it as a coarse fiber, medium fine, fine, and super fine fibers. It is always denoted as micrograms per inch. In Indian cotton, this value lies between 2.9 to 5.5. When I say 2.9, this is a super fine fiber. When I say 5.5, this is a very coarse fiber. Normally, Indian cotton falls in this medium fine variety, that is 3.5 to 4.5. Okay. Fiber strength. Fiber strength is measured as bundle of fibers only and expressed as fiber strength in gram per text. You can ask me, when you say fiber fineness, individual fiber fineness. When you say fiber length, individual fiber length. But fiber strength, we are calling it as a bundle of fiber strength. Can you measure individual fiber length? Fiber strength. Yes, we do that. But this is not useful for the industry. This fiber strength, individual fiber strength, can be measured by special instruments like Instan, which is mostly used by researchers to study the effect of dyeing or something like that in the later part. Okay, it is not at all useful for the industry. Okay. Fiber maturity. Maturity is nothing but the level of growth of the cell wall and its uniformity throughout the structure. Cotton fiber has wall thickness, which you mean by cell wall thickness. Let's see what is this. So see, here you have the wall area. We identify the wall area. This is called a cell wall. So how thickness it is, it decides your maturity level. So when the thickness is reduced, what is happening? Another part we call is the lumen. Lumen is the hole inside internal area. When the lumen is bigger, wall thickness is going to be shrunk. That means if the lumen is bigger, the cotton fiber is less mature. When the lumen is smaller, your cell wall thickness is good, your cotton fiber is more mature, something like that. Okay, but this can be measured only by the microscope, only by a cross-sectional analysis. Based on these measurements, we come into a conclusion of fully mature, half mature, less mature. So there are several methods for fiber maturity. HV also gives a measure of fiber maturity, but normally mills, whenever they find some trouble in maturity behavior, they go by research method of caustic soda method. Caustic soda method means they will allow the fibers to swell and then they will do a cross-sectional analysis of several fibers together in the microscope. Then they will identify how many of them are mature fiber, how many of them are mature, how many of them is no maturity, less mature. Based on that, there is a formula is applied. They will say, tell us maturity ratio or maturity coefficient. That research value is more important as far as the maturity coefficient is concerned. that value is the best value. Okay, whenever there is a problem comes in your factory, go to the research laboratory to test for the some mills, very big mills have some method of caustic soda method also. But an instrument cannot do this. Okay, this is a manual method. Then short fiber content, which we already discussed, lower than 12.5 mm is accounted, estimated, and reported as a subsidy percentage in HPA, high volume estimate. Then what is this reflectance and yellowness? This reflectance yellowness are two properties. Reflectance value range, this method by the instrument called colorimeter in the HPA. Okay. Reflectance of Indian cotton ranges from 50 to 85. When you say 50, it means a darker shade. It means a darker shade. When you say 85, it's a brighter and whiter shade. When you see two cotton, one is brighter and one is darker. Darker will have 50 value, brighter will be 85. So this is called a reflect. How much the light is reflected from the cotton. Based on that, the brightness of the cotton fiber is checked. Another is yellowness plus B value. This yellowness is also an important property. Cotton has a color. Natural cotton has a color because of this wax content over that. This color will vary based on the growth condition. So it comes from light cream, cream, dark cream. So yellowness, the yellowness of the cotton will be going on increasing. As the number increases, creaminess also increases. That means if it is 7, it's a light cream. If it is 13, it will look like your cream cloth, like a cream, so yellow cream, like that it will look like. Some foreign cotton will look like that. Okay. So whenever you mix two varieties of cotton due to economic reason, we should be very, very careful to identify these reflectance and yellowness values. So what is the level of difference between the two cottons on yellowness and reflectance? As per the research studies, as per the practical shop floor studies, then only you can go for that. You cannot mix a cotton with 85 and cotton with 50 together. So normally reflectance, the allowed range is 8, plus or minus 4 only we are allowed. In the plus B values, normally we are allowing plus or minus 1 only we can allow. That means you can mix 9 with 7. You can mix 80 with 72, like that. So reflectance and yellowness is for the shade variation, the yarn stage binary. So some of the sample values, for example, high volume industrial, what values you will get? 2.5% span length, it varies from 27 mm to 37 mm in Indian cotton. Uniformity ratio, it varies from 42% to 49% in Indian cotton. Why I am saying Indian cotton? Indian cotton is an average fiber quality is also there, high quality fiber is also there. But there are very good fiber from US, which has a different characteristics. It is excellent characteristics in comparison to Indian cotton. Mite value, it ranges from 2.9 to 5 in Indian cotton. Fiber strength, it varies from 19 to 27. SFC, it varies from 5 to 8 as per the HVA values. Okay. Now the next property, trash analyzer. See, one part we have completed. HVA, high volume institute for raw material testing, we have completed. The next part is trash analyzer. What do you mean by trash? In cotton, being naturally grown, it will come with seed coat fragments, leaves, even sand, even dust, everything will be coming. So look like that. There is a seed particle, there is a seed coat fragment, leaves, everything. Some black structure, some sticks are also there. So all things is called as trash. Trash analyzer, we will be using it mills to assess the trash content in the cotton. So we will take some 100 grams of fiber and then test non-cotton material. That is non-cotton material. What is the content of non-cotton material? Or you call it lint. Normally we call cotton fiber as lint also. What is the portion of non-lint material in the 100 grams sample? That is called trash content. Trash content is nothing but the percentage of trash to the raw material samples you are collecting. Trash means seed coat fragments, broken seeds, full seeds, leaves, and okay. Trash levels in India, normally it ranges from 0.5% to 7.5%. Normal range in Indian cotton is 1.5% and 4.5% also. It's a normal level. Okay. Normally, mills will not buy cotton with excess value beyond 3%. Rarely they will go for 3% and above. Normally, mills buy between 1.5 to 3%. For example, cotton from Gujarat S6, cotton from MC5 Andhra are all coming below 3%. But whereas cotton like DCH32 or cotton like MECH from MP, all this contain above 3% trash. Okay. Now we have completed the raw material inspection. We need to go for the in-process inspection. So the bale is taken to the machines, the bale is processed, you are opening the cotton and everything. So the process is on. So you will have a blow room, carding, lap formation, combing, draw frame, speed frame, spinning, and auto color. Isn't it? Binding, auto color, yarn conditioning, binding. So these are the process flow. So in this process, we are adding value to the product at each stage. So whether we are done that, this must be tested by us by a proper instruments. So that is where in-process inspection comes. In this in-process inspection tools, one of the very, very important tool is in preparatory is Office Advanced Fiber Information System. How we are going to use that, we will see. Then wrap block and wrap reel is a small thing, and there is a least strength tester, and there is evenness tester. Next comes this tester, then comes single yarn strength tester. Let's see one by one. This advanced fiber information system, this is also developed by WINSYS. This is also helped by USDA for process behavior. This is helpful to determine single fiber length. Please note, single fiber length it can measure. In HVA, we always say a clamped fiber, a fiber group is tested, and we won't say what is a individual length of the fiber, but here we can say individual length of the fiber. Okay. Then we are also seeing with the help of laser, we are able to identify what is a net present in the fiber itself. Okay. Then later developments, it has developed a maturity also in a precise manner. All these measurements are based on scanning of individual fibers. Almost 3,000 fibers are tested in a sample itself. So it is the most reliable instrument in the world today for individual fiber testing. So since individual fiber length is measured, we get the benefit of, we can get 1% fiber length, 2.5% span length, 50% span length. How do you test that? In the whole spectrum of 3,000 fiber, what length is contributed by the 1% of the fiber? What length is contributed by the 2.5% of the fiber? What length is contributed by 50% of the fiber? Like that, you can do anything, whatever you want. You can even do 5% length. You can do 10% length, something. Okay, you can program that. So this is the benefit of advanced fiber information system. Then, since you are able to do that, we are able to get short fiber content by number, percentage by number. Here also short fiber content is a 12.5%. So now you can count out of 3,000 fibers tested, how many fibers are below 12.5 mm. So that percentage will be called as SFC by number. That is called as short fiber content by number, which is most used test data for in-process control. Please note. Another is short fiber content in percentage by weight. It also measures the fineness of the fiber, thickness of the fiber, then the weight of the fiber. 3,000 fibers is also taken. Based on that, it measures the weight of 3,000 fibers, it measures the weight of the short fibers below 12.5 mm, then convert the weight by weight. That is given as short fiber content in percentage by weight. This is also being used by our spinners only for setting the noil percentage in Comber. Comber noil is how much waste to be extracted in Comber. This is decided by the short fiber content in percentage by weight. Okay. Another important is NEPs. NEPs are nothing but a small fibrous cluster, fibrous NEPs, and it can also be formed by some small broken seed coat fragment. That is small particle of a seed coat fragment, which is associated with some fiber. So NEPs which are made of 100% fiber is fibrous NEPs. NEPs which contain a part of seed coat fragment is called as a seed coat NEPs. So we must be very careful about the seed coat NEPs because seed coat NEPs is a contributing factor for higher end breakage level in the ring frame. Whenever the trash content in raw material is very high, chances of higher seed coat NEP is a probability. So to avoid that, normally to make it zero in Comber, we extract more noil or more cod waste. Okay. So Office instrument measure number of NEPs per gram of fiber, and it also estimates the occurrence of NEP based on its size. It also measures size of the NEP also 500 microns. NEPs above 500 microns. NEPs above 800 microns. Like that you can take that because that is helpful. Some heavy weighted NEPs will fall up during the process. Some small size NEPs will continue to the process even after processing. So we are more worried about the small size NEPs. Hence, Office is helpful for in-process control from blow room to Comber. In blow room, what is the NEP generation? In coding, how much NEPs is removed? In Comber, how much NEPs is removed? In Office, you can also see short fiber content in number. In Comber, we extract Comber oil. After extracting the Comber oil, Comber sliver can be tested. What is the improvement in short fiber content? Like that. Okay. If the short fiber content in the mixing is 30%. After combing, the combed sliver will have only 12% because you extracted 18% the oil. Like that. It may not match exactly, but it's approximately equal. What is seed coat NEPs? Seed coat NEPs is fragments of cotton seed that still have some fibers attached to them. Created mainly in ginning when the fibers are separated from the seeds. When the seed is not separated properly in the knife section of the ginning, seed will be pulled out or it is broken. Along with the broken seed, lint will come out like that. Removal of SEN is very difficult since the fibers tend to stick with the process. SEN is clearly visible as dark spot in the gray fabric what you are making. In order to reduce its impact, fabric has to be normally. Whenever you bleach the fabric, all this will get washed out. Okay. Office is also used to estimate the maturity of cotton, as we see. It is defined as the ratio of area of the cross section of fibrous wall and the area of the circle of the same perimeter as fiber. You have seen the fiber cross section. So for the same perimeter, what will be the total circle? What will be the reduced circle? This ratio is called as maturity ratio. Normally, the maturity ratio will be ranging from 0.85 to even 1.1, something like that. So higher the value, maturity is very good. But normally, Office maturity ratio is rarely used, whereas our maturity coefficient is very mature. Now coming to the process control, in-process control. In-process control is one of the tool for the testing of the process product, in-process products. For example, in a carding card slaver, in the drop frame slaver. Then in the lab, you have the lab, from the lab format, you have the ribbon lab or unilab or Comber labs, everything. So all, then again from speed frame, we have the roving. So all this must be formed into a smaller length. That is sometimes 6 yards, sometimes 3 yards, must be weighed for measuring the count of the material. So wrap block is a small instrument, it's a cylindrical surface with a 1 yard surface, okay, circumference. So wrap block will be used to wind slivers and rovings. If you revolve one, One revolution is 1 yard. Second revolution, 2 yards. Third revolution, 3 yards. Like that. You can go for a 3 yards or 6 yards or 15 yards. Normally, roving is 15 yards. Drop and slaver, we used to take 6 yards. 6 yards ball will be weighed and count is measured. Okay. This is for the wrap block. Wrap reel. Wrap reel. This is actually one revolution of this drum will be 120 yards. Normally, we say it's a, what is it, count terminology based on the 120 yards. How much 120 yards is weighing in a 1 pound is based on that. We have that. Okay. So wrap reel is used to wind the in 120 yards. Then so many 120 yards will be taken and weighed based on the weighment of this 120, which is called Lee. Based on the Lee weight, we will come to estimate the count of yarn. Okay. The same Lee will be utilized for strength tester also. This is called in the Lee strength. Lee is a circular thread, 80 thread of 80 threads of 1.5 meter or 1.5 yard, 120 yards. Okay. This circumferential thread will be laid in the two jaws of a Lee strength tester, and the bottom jaw will go down. It will stretch the yarn. So based on the breakage level, we calibrate the instrument for Lee strength. That's called Lee strength. When you call Lee strength, it's a bulk of yarn is contributing. This is strength of it, not the individual strength. Bulk of fibers is contribute. Bulk of yarn is going to contribute for the strength of this. So Lee strength is more used commercially by us, not the single yarn strength. Commercially, we always go by Lee strength. Almost in all India, but normally this Lee strength is not utilized elsewhere outside India. Very rarely used. Okay. Lee strength is normally expressed in pounds. What do you mean by count strength product? Count multiplied by strength of Lee in pound is called CSP. For example, if it were 60 is count, 40 lbs is the strength, 60 into 40, 2400. 2400 is your count strength product. CSP is 2400. But normally in a hosiery yarn, we operate with a level of 2000 to 2600. For a normal hosiery yarn, we operate with 2000 to 2600. It's enough. But if you go with a dyed knitting process, normally we go beyond 2600 to 3100 CSP. For warp yarn, the strength starting range itself will be 2500. It may go up to even 3500 based on the fiber used. Okay. Here, based on this Lee count CV is also calculated. So what is the spread of the values? The coefficient of variation of the count is also tested. The best value of count CV is 1.2 and below. But normally mills operate at the level of 1.5% count CV. Based on the strength measurement, we also express Lee strength CV. Best value is 3.5, and normally mills operate with the level of 5 and below. Okay, anything above 5.5, customers will reject. Okay, likewise in the count CV, if the yarn count CV is above 1.8, normally customers refuse to accept the product. Okay. Now coming to the another important tester. This is also made by Worcester initially. This is an evenness tester. So in 1948, Worcester developed the first evenness tester, GGP, Worcester GGP. Then after that, only after how many years? 1948, 26 years. 1974 only UT1. Normally we call this a UT1, Worcester tester 1, second generation of semi-automatic evenness tester has come. Then the same year, Worcester tester 2 also automatic evenness tester has come, but it's a quality-wise there's so much difference. 1987 UT3 has come, first digital evenness tester. 1997 Worcester tester 4, This is where you are able to measure the dust, trash, density, shape, diameter, and surface measurement of yarns. This is where your hardness is also measured there. To 2005 UT5, first high-speed multi-purpose laboratory system. For research purpose also, it can be used UT5 with the high-speed system, because up to that UT4, yarn speed is only limited to 400 meters per minute. Only after UT5, you can run up to 800 meters per minute, and speed is selected. 2015, the birth of boosted test 6, the total testing center, which has innumerous properties. Okay. This UT6 today, most of the reputed mills or corporate mills have bought it. The total testing center is a global standard in evenness testing today. It can be run at 800 mpm compared to 400 mpm of previous generation. It has so many sensors also for the fairness level, for the optical level, and upgradable for all sensor options. Basic machine also you can buy, or you can go for a knowledge-based system. That is, you can give input for key performance indicators in several departments of Worcester instruments, from preparatory, Worcester evenness tester, Worcester office, and everything. All data can be integrated in the total testing center. A holistic management system can be formed in this total testing center. That's why we call it a total testing center. More importantly, it can be linked with Worcester statistics. When the product is coming out, when the yarn is coming out, it will say your yarn meets Worcester 5% level, your yarn meets Worcester 25% level. Like that, it can certify your product also. So this UT6 has HL sensor, that is hardness length sensor. What is this hardness? We will see what is hardness length sensor and everything later also. Hardness means the number of protruding hairs from the surface of the yarn and the level of extent of this hairs. That also can be measured in the HL sensor. So this is OH sensor is the exact hardness index. Since FA sensor is absolute yarn count, including the hairs or any other thick and thin place variation. OM sensor is diameter variation. OM sensor is helpful for the setting of yarn during fighting. Okay. What is the benefit we are getting from this unevenness test? This U% is the percentage mass deviations of unit length of material caused by unevenness distribution along the length of the strand. It is a measure of irregularity of the mass over the length. How much irregularity over the length of yarn? For example, like this. So you have in the diagram, please see the diagram. There is a thin place, there is a thick place, there is a neb, there is a protruding hair. All this can be measured and expressed as a unevenness factor. And you can also get how many thin places, how many thick places, how many nebs, how many hairs. Everything you can get it in the Worcester evenness tester of yarn. So evenness tester we use from the carding stage itself for sliver unevenness. From card to drop rinse, sliver unevenness is measured with the help of Worcester evenness tester. Sliver unevenness is measured in U%, a measure of mass variation of the sliver, which is more important. We should be correct in the subsequent process, if not in carding. In each department, we expect improvement in sliver unevenness. For example, in card, it may be 4. In Coimbatore, we should reduce to 3.5. Draw frame, we expect a value of 2. So this is happening because of a doubling process. Because one or the sliver, we are adding slivers in every process. In a combing process, before combing, we are adding 24 slivers or 18 slivers together, and then lap is formed. So the evenness is created from the uneven slivers because of the doubling action. So it helps to even out the variations, and your evenness values is improved in every product. Okay. Roving unevenness. In speed frames also we measuring roving unevenness from the same evenness tester. In speed run, the expected best value for cotton roving is 3.5%. But please note, this is the last area beyond which you cannot improve anything on the product quality. This is the last area beyond which you cannot do any improvements on the output. If your roving has some imperfection, it will be multiplied in the yard stage. The roving has thin place, it will be multiplied in the yard stage. The roving has hairness, it will be multiplied in the yard stage. The roving has seed coat fragments, it will appear in the seed coat fragments in the yard stage also. You cannot correct anywhere. Okay. So before roving, what are corrections? You have to do that. And in roving, you have to form a proper roving package, and here you can measure unevenness and mass variations also. So coming to the ring yarn. In the ring yarn, all this coming under in-process inspection. So up to roving, we have completed in-process inspection. In the ring yarn, what are the in-process test parameters? Count and count its CV, we have seen. D-strength and its CV, we have seen. Twist and its CV. So twist is normally given to yarn to hold the fibers together, and also it has to manage the stresses in the subsequent process. So in a auxiliary process, the stress is less. So you are applying a less twist. In a warp yarn, in a weaving, there are so many beating up, so many jerking. So it has to withstand the stress. So we are going for a higher twist in the warp yarn. Like that, so twist level depends on the end use of the product. So we have to measure the twist level also. And this twist also uniformly spread over the length of the yarn. So CV of twist level, normally we expect 2.5% and below. Okay, one is the twist level, and there is the CV of twist level. Both you should understand. Twist you can give 20 TM, 20 TPA, or 24 TPA, or 30 TPA, like that, based on the requirements of the end use. Normally we call this a twist multiplier. Okay, twist per inch divided by root of count is called a TM, twist multiplier. TM is normally in auxiliary counts, it will be 3.3 to 3.7. In a warp count, it will be 4 to 4.6. Okay, simple terms you can keep in mind. 3.3 to 3.7 auxiliary count, 4 to 4.6 in warp count. Okay. Then is unevenness in imperfection, we will see later. Single yarn strength. So what we see as a least strength is a bulk strength. Bulk of the yarn is given and stretched. So that's called a bulk representation. But we need single yarn strength. Why? In warping, you are suspending the yarn and running it to warp. So we need single yarn strength, how much tension it can withhold. So we need to assess the single yarn strength value before giving to the customer. So single yarn strength, the hardiness of the yarn. When I say unevenness in imperfection, we have seen the U% value, thin, thick nibs. Okay, these thin, thick nibs are, you have seen the diagram. Thin means minus 50% of the yarn surface. Thick means plus 50% and above the yarn surface. Nibs is plus 200% of the yarn surface. We also have plus 140. We also have plus 280 also. But normally in spinning yarn imperfection, we say minus 50 plus 200% level. This is the normal level of imperfection and normal. But we also follow higher sensitive faults. If you measure minus 40% thin faults and plus 35% thick faults and plus 140% nets, we call it as a higher sensitive faults. Okay. And Uster evenness also helps you to find out yarn hardiness. This we already see. Apart from these parameters, we also have one more parameter called classmate faults. When you say U% thin, thick place and imperfections, it's called as periodic faults. Periodic faults are caused by, which is having a repeatability. You will have a top roller diameter is cut. There is a cut in the top roller. Then it will introduce a periodic variation. Or the bottom roller is eccentric. It will introduce a periodic variation. So it is a repeatable imperfection. So short-term imperfection means it's a repeatable, periodical imperfections. But when you say classmate faults, it is not repeatable. It's a random faults, randomly occurring faults, not necessarily repeatable. Okay, this is not due to your machinery fault alone. It can be due to so many faults. Okay, it can be caused by the machine cleanliness. It can be caused by the environment conditions, or randomly coming intermittent defects in your machinery parts also. And it also gives a measure of opening and cleaning quality in dormant cards, because you have 6 cards for a particular process. In the 6 cards, 1 card is defective production, defective, some nebs are more. Then whenever that product comes, the yarn neb will be improved. Necessarily, you cannot say that always the card number 6 will be coming to the yarn. If the process is not properly channelized, sometimes it will come, sometimes it will not come. Then classmate faults will be a random one. Then the effectiveness of the drafting behavior, cleanliness of the machine, and environment inside the department decide the classmate fault. So it's a simple table. Okay, you need not worry much about this. Later you can study. But the bottom part is a thin fault, top part is a short thick fault series. Okay, this EFG is a long-term fault. EFG is a, we call it a long-term faults. Okay, here we have mentioned as diameter. Here, this part, y-axis is a diameter, x-axis is a fault length, length of the fault. For example, if the fault is 1 centimeter and diameter is 150, we call below 150, we call it as A1 fault. Fault length is 1 centimeter and fault diameter is below 150% of the yarn, we call it as a A1. Likewise, D4 is 8 centimeter length and above 400%. 8 centimeter length, 400%. So based on this classification, we classify these faults as objectionable faults, drafting faults, spinners doubles, long thin faults and long thick faults. But beyond that also there are so many faults which is used by the researchers or which is used by very, very sensitive customers, sensitive vendors. Okay. But these are enough for a spinner to set the machine for a very good quality fabric. Okay. So these are all necessary for setting the autoconer yarn clear. Okay. Then comes, we discussed about single yarn strength. In the single yarn strength tester, we have 2 instruments. One is type of tensor rapid and there is a tensor jet. In the name, there are several instruments in the market. That's also there. Okay. UTR is used for single yarn strength and elongations. What is the single yarn strength in grams, or it's expressed in RK, resilience kilometer, in kilometer. So elongations are how, what is the elongation property of yarn? Whether it's a 7% or it's a 5% or it's a 4.5%. But it also measures the CV, coefficient of variation of these values also, this UTJ. But UTJ, apart from these values, it's a high-speed instrument. So when you say high-speed instrument, when the yarn is run at high speed, continuously it is be running. And it will be testing the yarn also by stretching and by elongating that. So when you do that, you are simulating a condition in the weaving. In the weaving, what is happening? Continuously yarn is moving up and down. At the same time, it's moving also. So horizontal movement as well as vertical movement, both are happening in the weaving. So the stress level with which the yarn is facing, that is being simulated in UTJ, twisted tensor jet. So whatever you get as a single yarn strength values in UTJ is a high speed rating. It will give you very good value for your assessment of the performance in the weaving stage. That is why UTJ is used. But normal conditions, UTR is more than enough. Whenever you go for high-end use of yarns, then we recommend twisted tensor jet. Twisted tensor jet is also gives deep places. So it gives a scatter plot. Scatter plot means X-axis is a elongation. Y-axis is breaking force. That is, single yarn strength is given the Y-axis. Elongation of the yarn is given the X-axis. So this is graphically represented here. So bulk of the values stay at somewhere in 25 and 7.5. Bulk of the value centering will be 25 RKM and 7.5 elongation. But see that yellow portion. In the yellow portion, there are some values. Elongation is also weak. Single yarn strength is also lower than the 13 RKM. Elongation is also below 5. This area is a weak area. This is called a weak places, total weak places. These weak places should be eliminated in the yarn by your proper process control, by your setting in spinning, by your setting in compact zone, which is a compact yarn, suction pressure level, and everything must be set. Even sometimes your traveler itself will spoil your yarn strength. So everything must be analyzed. This zone is scatter plot is more useful for testing for eliminating the weak places in yarn, which helps to improve your yarn behavior in the weaving. Okay. Twist we already seen. The level of twist is dependent on the type of induce. Embroidery, very soft twist we give. Osieri soft twist, warp yarn normal twist. Which is a voile fabric, we normally give high twist yarn. Twist is normally given the Z direction. Sometimes we give in S direction also for a special paint use. Yarn twist measured in the ordinary twist tester. Manually also you can do. There are electronic digital twist tester which does the function automatically and gives a result in a digital form. Yarn hardness tester measures the protruding hairs beyond the surface of the yarn and expressed as an index. Worcester hardness index also can be made available to the Worcester evenness tester, and Swigel yarn hardness tester measures the extent of yarn length, number of hairs above 12 mm, number of hairs above 10 mm, number of hairs above 3 mm. That's also being done. So this is the yarn hardness. See, some of the fibers are protruding small extent, is 3 mm to 5 mm. Some of the hairs are long hairs. These long hairs are a disturbing factor while going for a further process. So, in the later stage of your spinning process or a post-spinning process, you will come to know about a process called singeing. That is, these hairs will be burnt by flames. So that's called gassing or singeing. So hairiness should be eliminated. When the hairs are eliminated, your lustrous property of yarn will be improved. It will become brighter. Okay. Now we have seen the in-process inspection of all the cones. Now your cones are ready. Your cones are ready in the autoconer. Final process inspection. So we have to inspect the cones. When you say cones inspection, there are certain statistical procedures as defined by many statistical associations like Bureau of Indian Standards and world level statistical institutes also. They give some. For example, if we take one lot of 170 bags, what number of cones you should do, what number of bags should be, how you should be picked out, everything. Okay. And sometimes customers also will specify for every lot of 170 bags, you should choose so many bags, so many cones, and let me know the results of such cones. Okay, like that. So you have to go with customers' need, failing which you can go with the standard conditions as reputed institution by BIS, Indian Standard Institution. Okay. But you should check for stated needs. We already seen implied needs, perceived needs. You should check for implied needs also. Even though it is not spelled out anywhere, you should check for implied needs also. Implied needs, what is that? You will see. Stated needs is count CV of yarn should be below 1.2. Strength CV of yarn should be below 4.5. Total yarn imperfection min 30 combed osier yarn should be below 40. single yarn strength should be 160 gram, or RKM should be 16.5 RKM, and its CV should not exceed 9.5. Yarn hardness should be, Mr. Hardness index should not exceed 5, and its CV should not exceed 5.5, like that. So it's a stated need of the customer. So against this specification, you should test such a number of cones and then give the results to them. Okay, this is final process inspection. Implied needs. What is implied need? When we say hosiery yarn, how the hosiery product is made? Normally, maybe a 24 cones or 36 cones or even 96 cones will be continuously revolving around a cylindrical body. So it will be a section of 24 yarns or 48 yarns or 96 yarns continuously knitted. That is first batch of 24, second batch of 24, third batch of 24, fourth batch of 24. So all the yarn should be uniform. All the yarn should be uniform in their classmate pulse, hardness level, count CV, and everything. Otherwise, when one yarn behave poorly, you will have one yarn in every 24 is a defective yarn. You will get a line in the okay. Then, likewise, if some of the yarn has some shade variation, one yarn out of this 24 yarn has a shade variation. That means some mix-up of product in the process. Or one yarn in a 40s product, one yarn of 30s is mixed. So that will cause variation in the product. So implied need, hosiery yarn should not lead to any barrenness in the fabric. This is called a barrenness or patta. In commercial term, it's called a patta defect. Barrenness should not come. Barrenness can be caused by so many reasons: twist variation, yarn count variation, mixing, reflectance variation, yellowness variation, raw material variation, everything. So we have to identify. So hosiery yarn should be checked in UV lamp chamber and checked for shade variation itself. So the implied need of the customer also you should be inspected by you. Because if there is a patta variation, the entire lot will be rejected. Next, warp yarn. Warp yarn should not have breaks during warping or wefting session, isn't it? So that is why we discussed about strength test, UTJ. Weak places should not be there. So you should test warp yarn for scatter plot. Sewing threads should not have snarls during sewing. That means snarls means it's a twisted strand. It's a, if you leave the yarn like this, yarn will shrink in between. That comes as a snarl. Snarl should not come in a sewing thread. Why should we say like that? Because your sewing machine today's speed is around 6,000 to 8,000 stitches per minute. In the 6,000 to 8,000 stitches per minute, even if it's a small snarl, thick place comes, needle will broken immediately. That will become a major complaint, needle breakage complaint from the sewing machine manufacturer. So, how do you control snarls? Snarls is nothing but it's an impact of either twist variation or improper twist setting. Twist setting, normally we use yarn conditioning plant in the spinning mills. All cones are set for 45 minutes in the yarn conditioning machine, then only yes. Even for hosiery yarn, we do that in a yarn conditioning plant has several purposes. Okay, but for yarns meant for sewing threads, always we do conditioning plant for twist setting, so that knots are not there. Okay. Implied needs. Whenever you buy milk, you won't say to the vendor that I need a milk which won't sour when I boil it, isn't it? So milk should not sour. There's an implied need of you, isn't it? So like that, hosiery yarn should not lead to barrenness, warp yarn should not have breaks, sewing thread should not have snarl. This is a basic implied need, isn't it? They will not say that, but they expect that. Okay. This also must be taken care of. The stated needs, you'll be doing the random selection of cartons or bags, 10 per lot of 170 cartons, approximately 75 ton, 2 cones per carton. This is ISI procedure. Check for visual defects of 20 cones. Check these 20 cones for all stated needs as per the invoice detail, or you should have your own final product procedure. Pass the lot only if the specifications are met with statistical significance. We are not covering statistics today. Statistics we can cover it separately, but understand, pass the lot only if the specifications are met with statistical significance. Okay. For series products, all cones are tested under UV lamp to avoid shade variation between cones, which is the source for shade variation. War cones, normally, instead of scatter plot, you can do rewinding study in autoconer also to simulate the condition of warping. Warp and weft air jet looms, tensor jets are used to find out weak places in yarn and correct it. Okay, this we already discussed. Most important, quality of packing material. You have made a very good product. You made a raw material inspection. You made in-process inspection. You made final process. But if your packing material quality is poor, what will happen? During the transportation, everything will be spoiled. Customer will not get what he wanted. Even though you have tested everything, you have confirmed with the quality specification. You have produced the cones without shade variation. But when he gets a deformed cones or a crushed cones or strained cones because of your packing material quality, so your image is going to be spoiled. So you have to inspect your paper cone quality for its strength. You have to inspect cotton box for its quality, bursting strength. You have to inspect your PP bags for its lamination, unlaminated lamination, because water should not enter into that. And finally, wooden pallets. Sometimes wooden pallet we row by row, we stack the cones and use stretch wrapping, then send to containers. Some countries accept stretch wrapped wooden pallets. This wooden pallets is a source for termites. So termites should not be there in the wooden pallets. Wooden pallets should be inspected for that. There is a process for that. To avoid the chemical treatment is also there to avoid the pest in the wooden pallets. So these wooden pallets are actually in one of the mills where I worked. It's a very good exports to Germany. The mill is sued for termites in the wooden pallets by the government of Germany, not by the customer, government of Germany, because they told that our port is polluted because of the termites in our wooden pallets. We are paid because of our inspection failure of wooden pallets. Non-quality requirements, we already seen the customers of spinning mills vary from weavers, knitters, garment manufacturers, value-added group. Based on that, we have to do that. This is one of the graph you should remember in your life whenever you say it's a quality management. This is a graph interesting. Most of our products characteristics follow the normal distribution, and textile products we sell with 95% confidence limits. 95% confidence limits means 2 sigma limits. Our values will fall in this normal distribution between the 2 sigma limits. Whenever your count is 50, the count with 1.2% counts 2 sigma limits. It will vary between 48.8 to 51.2. Like that only we said. Like the count strength also. Single yarn strength, least strength, everything. We normally say we follow normal distribution. 95% of values only we are assuring. We don't assure beyond 95%. Because you should remember that sometimes you may join in a sales job. When you join a marketing job, some customer will come and say, you know, 50 yarn, I'm experiencing only 49.5. I cannot accept. Then you should say, the value will fall within the range of so many, because I have committed 1.5 count CV. Our count range will be like this. Like that, you should be able to say that. So that's why I'm telling you, this graph is more important for you. Then you have managed well in the inspection, but customer must get satisfied. So customers will not tolerate on the poor service provided by your marketing department. The quality of communication of the marketing department is more important. And you also should get feedback from the customers. What is the product quality? How do you find? Do you face any problem? Do you face any kiddies in my fabric? whether the fabric appearance is good at your end. Like that, you should get feedback also. So when you say customer satisfaction measurement, normally customer is satisfied like this. This is a global survey. They are satisfied, beyond quality satisfy them at the level of 30%. Next comes end use performance, whether knitted fabric doesn't have any kitties, knitted fabric doesn't have any barrenness. In weaving yarn, there's no breakage, weaving efficiency is not affected, then gives 30%. Then the quality of packing, they give importance of 10%. Then the adherence to delivery, 10%. Are you dispatching in time? Quality of sales staff, the communication, whenever they ask for some adjustment, tailor-made products, is the sales staff is giving respect to that request. Quality of agents, agent must take back that feedback and giving to you, then give your comments to the customers also, like that. What is the quality of agent? Like that. Say one part of your measurement. So you should have a customer satisfaction measurement system also in your place. Now coming to what we have seen in a spinning mill, we have seen about cotton fiber. But let us touch upon the synthetic fiber properties. In synthetic fiber, it's a machine-made fiber. It's a chemically modified structure. Whether it's a rayon or a polyester, it's a machine-made fiber or injection program, spinnerets. Here, cut length is common. You can get it 34 mm or 38 mm for your specific cut length. They manufacture it specific cut length. Here, sometimes the blade fails. So one turn fails, then the next turn will be, instead of 40 mm, you will get a 80 mm. So when there is a cut length failure, then you get a over length also. So you need to know the cut length and you need to know the over length percentage. Over length fibers means anything extra than the cut length. So you should have a CV of, measure on the over length fibers. How many over length fibers in the given sample? You should have measured for that. Then the fineness is normally expressed in denier. 0.8 denier to 1.4 denier is the normal range of the short stapled system for this. Strength of this synthetic fiber is expressed in grams per denier. For it ranges from 2.4 in viscose to 7 GPD in super high tenacity polystyrene. Then it has some spin finish so that the process is smooth. And then the number of creams for matching your convolutions in cotton, which you will see later in your subject in the textile physics. Normally, mills don't test these characteristics, but believe are dependent on manufacturer's specification because it's a machine-made specification. But very good mills which want quality, they always seek the help of research association in the estimation of these fiber characteristics. This fiber characteristic estimation is a tough process. Length, normally they follow with the BISPA oil plate method. For one sample testing itself, it will take 2 hours. So Citra itself is trying to avoid such kind of test because it's very difficult. Linear is a microscopic analysis. GPD, instant tester is there following. This is also some costly instrument which you cannot buy and keep it. So let's come a conclusion. What kind of testing instrument for cotton and synthetic? HVA, cotton, it is used, synthetic no. BISPA oil plate method for cotton no, synthetic yes. ABIS only for cotton, not for synthetic. Trash analyzer only for cotton, synthetic no. Whereas RAPRIL, RABLOCK, evenness tester, classmate tester, least strength tester, single land strength test, UV chamber, everything is used for cotton and synthetic. But there's one more instrument which we are not tested, which we are not discussed, is UV torch. It's a small kind of testing instrument, which is used to test from the blowroom itself. By using this torch, if there is a variation in the fiber finishes, then you will come to know there's a merge number variation. The synthetic alone, we normally use it because it will lead to shade variation in the final limit. So UV torch is also used in the synthetic. Normally for cotton, it's not necessary. Before closing down, I would like to touch upon is two slides on the total quality management. TQM is a well-known concept, widely applied by all quality conscious manufacturers from 1960 onwards. In India, only textile mill which has first initiated the total quality management is Sundaram Textiles in Madurai. They are the first people who got the TQM. Later, there are some mills not who got the TQM, but other mills like Tyagaraja mills and premium mills are working towards TQM. They have not got any awards so far. Key takeaways are TQM are you have to build the quality into the product through ZDQC concept, that is zero defect quality control and COQ, cost of quality. So, how do you achieve this? What are the tools of TQM? ZDQC, zero defect quality control concept, by building the quality to the product. That's one concept. Daily meeting, that is every day for 20 minutes, your unit head, unit manufacturing head should discuss with maintenance, production and quality, and even the training manager to review what went wrong yesterday, how to improve today. Daily meeting. It's a 20 minutes meeting, short meeting at shop floor. It's a daily meeting. Then fishbone analysis. Fishbone analysis is nothing but like a fishbone. Imagine a fishbone, how it look like. It will look like this, then it will look like this, but it will look like this. Fishbone. So anything, any defect in a material is caused by men, material, machines, and methods. So these 4 bones. So any defect you should try to analyze men, material, methods, and like that. You should have a fishbone analysis for every defect. Then knowledge bank, whatever you learned, whatever you studied as a trade, or whatever customer given feedback and then improvement, this should be put in a knowledge bank in your data system, so that whenever you say, whenever you find a stained cone, then what are the causes for stained cone? You should get a data. So immediately you will go back and attack. Whether you are there, whether A is there or B is there, they should be able to attack immediately. The management cannot wait for the quality control manager always. They should ask the production manager and search for the stained cones and correct it immediately. So knowledge bank should have a data of the actions taken by you on everything, every defects, every customer feedback. Then customer satisfaction audits you should conduct. Then process and quality audits in the shop floor. Then the other subject is a failure mode effective analysis. This is actually another subject. This is almost equal to a fishbone analysis. Failure mode effect. What are all the causes for the failure? Maybe a breakdown. Failure, you can call it a defect also. Why the badness is coming? Why the bar beam breaks are so high when you compare to J. mills? Why my bar breaks are so high? Like that. This is all coming under FMEA, you can study. Now we are coming to a closing of this session. Now you cannot restrict with what I discussed with you today, because voluminous subject, quality management results. I recommend you to read further in quality management. These are some books which you can read and learn whenever you have the time. Throughout some of you have 1 year time, some of you have 3 years time, like that. So Principles of Textile Testing by J.E. Booth is a more important book on testing. Textile Testing, Fiber, Yarn and Fabric by Dr. Arianda Pasu of Citra. Quality Control in Spinning by T.V. Ratnam and K.P. Chalamni of Citra. And Process Control and Yarn Quality in Spinning by Dr. Dilagodi Madam, your own head of the department, and Dr. T. Karthik. And Manufacturing Excellence Spinning Mills, authored by me. These are all some of the books which you can go through in your course itself, so that you will enrich and enhance before you face the industry. I thank all of you. I thank the Textile Association as well as both PhD and Bannari Institute of Technology and all the students for a patient hearing. Thank you. Gandhiraj sir.
Yeah, thank you, Mr. Kanthimathinathan, for a detailed, well elaborated presentation and made suitable for the students. Hope this would have given a very good insights on the testing, quality management in spinning mill. So now I request Mr. Gopalakrishnan. I think he's online. Mr. Gopalakrishnan, sir.
Yeah, good evening, sir.
Can you your inputs on the presentation slide?
Yes, sir. Yes, sir. So
Yes.
thank you, sir. So respected Secretary, Mr. Gandhiraj, Mr. Kanthimathinathan, and Mr. Sivaramakrishnan, and other members of Textile Association of India, South India Unit, and my teacher, Dr. G. Tilakvadi, Head of the Department, Textile Technology, PhD College of Technology, faculty members of Bannari Institute of Technology and PhD College of Technology, students of PhD and BIT. Yeah, good evening to one and all present here. On behalf of Bannari Institute of Technology and on my own behalf, I thank Textile Association of India, South India Unit for providing a wonderful service for us. Exactly 1 year before we started this students chapter, and we covered more than 6 webinars during this period. Which were covered in the webinar, increase the possibility of placement of our students. The webinar is not only improves the knowledge of students, it also enhances the knowledge of our faculty members. And we are in the end of first year and we completed with great success. This is only possible with good organizing skill, knowledge and experience. The members of TAI-SIU have all these qualities and they are in service motive, and they conducted it some precision. So hope this will continue in coming years also. And coming to today's presentation on quality systems in spinning, Mr. Kanthimathinathan have a great knowledge on this area, and he written a book on this topic, and the book is covered all the areas of quality, and it is a great book. So if you have a chance, please read this book. And in his presentation, sir covered the different definitions of quality, the details of HVI instruments, span length, fineness, maturity, trash, office, least strength, count, evenness, hairiness, unevenness, and classmate analysis, single ion strength, and quality of packing materials, and finally TQM. So all these topics are explained in industry perspective with some statistics, and this will be good for our students to understand better in classes, and this will also enhance the knowledge while going for a placement. So thanks to Mr. Kanthimathinathan for giving a wonderful presentation. Once again, I thank all the members. Thank you.
Thank you very much, Mr. Gopalakrishnan, HOD. And now we come to the end of this program. Now I request our Joint Secretary, Mr. Sivaramakrishnan, to deliver the formal vote of thanks.
Respected HOD Madam, Gopalakrishnan, teaching faculty and students. Today we are very much grateful to our Sri Kanthimathinathan because he has selected topics like Palnini Dutum Tayinum Salaparindu Indra Upper Burmanuடைய பாடலுக்கு ஏற்றால் போல he suggested more than 8-9 topics in the last committee meeting. Based on that, the first quality management in spinning, he has explained everything starting from raw material, in process, final product, packing material, and customer satisfaction. Then up to TQM, he has explained everything like our Avayar attitude. Seeing he has explained everything in a simple language, slowly, calmly, quietly. It is penetrating into the young brains. No one can explain better than him. This is what my conclusion. No one is better than him. This is my conclusion. No one can explain like this. It is so much of light, very simple language, very easily understandable manner. He has explained everything. It is penetrating like an arrow in our students' mind. He has given a very good thing. If all our textile technology students studied in depth all these presentations, they can come out successful in their any interview. So starting from HVI, office, and 8 instruments in yarn quality, he has explained how HVI can be selected and how office can be used for controlling the raw material quality, blow room, carding, combing, drawing. See, all these things will be nicely explained. Short fiber content by number, short fiber content by weight, everything is well explained. So we are very much thankful for his presentation. So we expect in coming programs, many programs will be taken by our Kanthimathinathan ji, which will be very much useful for all students. So my humble request to all dear students, kindly go through all these slides. You are going to succeed in all your interviews. Whatever questions asked by the interview panel members, you are able to explain. So please kindly go through all these things, come out successful in the interview. So our thanks to HODs, professors, teaching faculty, Kanthimathinathan ji, and also all our dear students. So with these few words, I will conclude my vote of thanks. Thank you very much.
Thank you very much, students and the faculty members. Now here I have a small announcement for the students and the faculty that we have, as we have started the student chapter, now we thought of giving the membership card to all the students, ID card to all the students who are a member of the student chapter. And we have already, Mr. Kanthimathinathan has already forwarded the format in which the students' details are needed. We kindly request you all to send those details immediately because we have designed the card for the students. And once we receive those details, then we can prepare the card and give it to all the students as a student chapter member. So we kindly request you to send those details at yes possible. And thank you very much. And let us all meet in the next program. Maybe in another 15-20 days. We are trying to have two programs in a month. Let us see how it goes. If everything permits and if things goes well, we can have more number of programs. Thank you very much. Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you very much for all.